Hello, welcome back, dear students. Today I'm going to solve for you the next paper. It is October-November 2024, paper 4, variant 3. It's a good exam, so please pay attention. And if you have any issue, you can post as comment any help extra needed. I'll be there to help you. First question. It says that state the difference between a scalar and vector quantity. You know, scalar quantity has only magnitude. Vector has both magnitude and direction. Let's write the answer. Scalar has magnitude. Magnitude means numerical value and no direction. Vector has both magnitude and direction. Meaning of magnitude is numerical value. So the main difference is scalar, no direction. Vector, it has direction. It will award you a mark. Define momentum. You can say it's a product of mass and velocity. Product of mass and velocity. Those students who want to write like that, momentum is equals to mass multiplied by velocity. It is also correct. You cannot write symbol equations. Please avoid symbols. Let's read part 2. Part 2 says, a test car crashes into a barrier to test the safety features. The test car has total mass 950 grams. You can underline this and give a symbol m. It is moving with a constant velocity from time 0 till 4. Okay, at time 4 seconds, the car hits the barrier. So it means the total time taken to hit the barrier is 4 seconds. Figure shows the car as it hits the barrier. During the test crash, the resultant force is this. You can underline this number, which is the resultant force, F. The car takes 1.5 seconds, it's a time t, to come to rest, final velocity is 0. So time taken, 1.5 seconds. Rest means final velocity is 0. The deceleration is uniform. Find the initial velocity. So you will use the impulse equations or the definition of force. Impulse, we know that it is represented by two equations, which is force multiplied by time and mass into change in velocity. You will substitute the values. The force is 27,000 Newton. Time taken is, as I told you, 1.5. So here you took the force, 27,000. From here you took the time, which is 1.5 seconds. You substitute the values. Mass. Mass they gave you on the top of the question, which is 950. You substitute mass here, 950. Final velocity is 0. Initial was unknown. You can rearrange and solve this equation. So 27,000 times 1.5 over 950 is negative u. So u is, which is going to be, if you rearrange and calculate, as I always told you, I already told you that, first of all, you have to write the actual answer. Once you wrote the actual answer, then you will round to two significant figures. So let's calculate the actual answer. It's going to be 27,000 times 1.5 divided by 950, 42.63. I'll write three significant figures, 43 meters per second. Dear students, the meaning of negative sign means when it hits, its speed decreases or it decelerates. So that's why negative. You will not write the negative with the final answer. We proceed to the next part. They say, sketch the speed time graph to show the motion for the car until car becomes stationary. I just told you a while ago that speed decreases, the negative sign means that. So since its deceleration is constant, if you go back in the question, so since the deceleration is constant, so it means the gradient of this graph will also be constant. So constant gradient means the graph has to be a straight line. Graph has to be a straight line. So go back, make a straight line until it stops with the help of ruler. So you will have this graph. Initial velocity, what you just calculated, 43. This number is 43 and until you become 0. Next, we proceed to the question number 2. Describe an experiment to determine the spring constant of a spring. You should state the apparatus, details of measurements, how to calculate the spring constant. You may use the space to draw the label diagram. Certainly, we will use. So spring constant, first of all, think what is that? You know Hooke's law. Hooke's law, my dear, says F is equals to Kx. So spring constant is K, which is F over X. So it means we need to know how much is the load, which is force. We need to know extension. So for extension, we need original and new length. So what you do, my dear students, experiment, a very basic experiment. So I'm going to show you. Like, for example, over here, you have a stand, a rough stand I'm making for you. Like that. And over here also, with the stand, you will have first of all, a spring, which is without any load. And then the same setup you will repeat with load. So I'm just copying to just guide you how this is going to work. So in this case, this spring, as you can see, this one, so you will add a new load or just the load. Spring will extend. Here is the load. So this load is in the form of a mass or whatever you want to say. It is as a mass. Okay, so what you'll do, you will tell that you will measure its original length using meter rule. Then you will measure its new length, loaded length, also with the meter rule. You can say L1. And now you need to explain the process. So what you have to do, as I mentioned for you, start in a sequence. So first of all, you will measure original or unstretched length of spring using a ruler. After that, you will hang the load or mass. I'm saying load, okay, on bottom of spring. What will happen? It will extend. So again, using meter rule or ruler, measure new length of spring. Then you will calculate extension of spring by subtracting new length minus original length. So far, we got the extension, my dear students. After that, what do? You calculate spring constant using equation K is equals to F upon X. Here, I want you to write the key where F is weight of load and X is extension. Now, let's go back to the question. As they told you that you must describe the experiment, label diagram, apparatus, details. Okay, this is perfect. So this is going to give you 4 marks. Each and every point I have written for you. If you have a question, you can ask me, my dear students. We proceed to the next part. Figure 2.1 shows a baby in a baby bouncer. The baby bouncer consists of a holder suspended from a spring. The baby pushes his feet on the ground and bounces gently up and down. Okay, so you can see the total height of the hook from the ground is 140, while the height of the spring from the ground is 100 centimeters. Two springs Q and R are tested to determine their spring constant. Each spring is tested up to its limit of proportionality. Define limit of proportionality. So you can say it's the maximum force up to which extension is directly proportional to the load. Dear students, do you know that as we keep applying more and more load, for example, here is the load F and here is extension X. So you know that as you keep applying the load, the extension is directly proportional, but eventually when it curves, so it means you have crossed the limit, this is the limit of proportionality. So after which there is no more proportionality. So this is the ideal definition which I gave you. We go to the next part too. So you have two springs, spring Q and spring R. The total weight of the baby and the holder is 120 Newton. Calculate the extension of each spring for this weight. No problem. We will go to the question and calculate the extension. Let's go for spring Q here and spring R over here. So spring Q, as you can see that the initially spring constant they gave you and the load is also given. So you know this triangle, my dear students, it says F is equals to Kx. So extension will be force, which is 120, divided by spring constant for Q. You will take from here and plug in here. So it is going to be 7.8. So 120 divided by 7.8 is 15.38, which rounds to two significant figures, 15 centimeters. So here also R, I'll go to the right side. Over here, extension is force over K. Force, again same, 120, K is 1.1. So what you have to do, 120 divided by 1.1, 109.09. So again, you will round to two significant figures and write here, which will be 110 centimeters. Don't forget to write the right unit. Why did I write centimeter? Because as you can see in the question, it was Newton per centimeter. So I kept them centimeters. And final answer should be rounded to two significant figure. The reason is the given data is also two significant figures. Let's go ahead to the next part of the same question. Now, unstretched length of each spring was 25 centimeter. This is called original length or unstretched length. Okay, straight explain which spring would be more suitable for this. Go back. Original length is 25. Now you go back and extension in first spring Q is 15. Okay, the second string is 110. This 110, if you compare with this number, okay, with 25, it is much more. So R is not suitable. So which one is suitable? Q. The reason is that the extension of 110 centimeter for R is too large for bounces. Okay, in given space. Baby may fall, yes, or baby may collapse. Dangerous. Okay, so it is dangerous for the baby, unsafe for baby. So any point could be written. It's a very interesting question. If you have a question, you can ask me. Let's go to the next question. Number 3, my dear students. Let's read the question. The figure shows the portable shower used on a campsite. The bag is filled with water. The water is heated using infrared radiation from sun. So it's a shower head, the shower bag. Okay, why shower bag is painted black? You all know the black is a good absorber of thermal radiation or infrared radiation. So black color is good absorber of. Don't forget to write the name of radiation, so absorber of which radiation? Either say thermal or say infrared radiation. Don't forget to write the name thermal or infrared radiation. Next question. Explain a disadvantage of radiation from sun being only source of heat for water. Yeah, because the radiation of sun, the nighttime, they are not available. Okay, so solar radiation, you can say, or radiation from sun are not available at night. They're not available at night. Okay. Solar energy is renewable energy resource. Uh, State two other renewable energy resources. Dear students, everything except nuclear and fossil fuels. Everything except nuclear and fossil fuels is renewable. Whatever comes in your mind, other than these two, you can write. So for example, you write over here, tidal, geothermal, wind, wave, biofuel. Biofuel is burning the crops, okay? Biofuel, even hydroelectric. Everything could be written other than nuclear or fossil fuels. I hope it is useful for you. Is that useful? Then you have to comment. I'll wait. Promise? Let's go ahead. Part C. During the day, the sun shines on shower bag, and some of the thermal energy from the sun transferred to thermal energy stores of water. Water absorbs 60% of the energy, and temperature rises this. Specific heat capacity question. So temperature rise, first of all, take it out. So delta T is 43 minus 10, which is 33 degrees Celsius. Okay, let's keep reading. Now they say the mass is this, take it out. Mass, we have 40 kilograms. Keep reading the question. Specific heat capacity is a lowercase c. Take it out. Is 4,200 joules per kg degree Celsius. Calculate the energy incident. Okay, so first of all, we will find the energy absorbed. You can say E1 or something like that. When you use the equation for specific heat capacity, as I always tell you that learn this way, E absorbed is equals to M cat. Substitute the values over here. So you will get E is equals to mass 40 C 4,200 times 33. This is the energy which is absorbed by water. So 40, 4,200, 33. This comes to be it's like a standard form. You can write 5.544 into 10 power 6 joules. Now, this energy which is absorbed, this is actually 60%, as they told you. This is 60%. So, how much will be 100%? So, you can just crisscross. So, the total energy incident will be 5.544 10 power 6 divided by 60 multiplied by 100. This comes to be total energy 9.24 into 10 power 6. Now you will round it to two significant figures over here, which will be 9.2 into 10 power 6 joules. Let's go to the next part. So what did we do? We organized the data first. That's the first step. After that, you found how much energy is absorbed, and then you found the 100% by dividing 60. So because this absorbed was only 60%, this only 60% was absorbed. So total mean we need 100%. So we divided by 60, multiply by 100, you get the answer. Let's proceed to the next question, my dear students, which is question number 4. Optics, my favorite. Figure shows a ray of light as it enters the side of plastic block. The ray passes from air to plastic. Okay. Incidence angle is 45. Refraction is 30. State how speed, wavelength, and frequency of the wave in plastic compares with air. You know that when it goes from air into any other medium, what happens? Speed decreases, wavelength decreases, frequency remains the same. So that's what they are asking you. Speed, you will say remains the same, or you can, the speed decreases, as I told you, slows down because it bends closer to normal. Wavelength, you know that V is equals to F lambda. So if V is decreased, it slows down. So wavelength also have to decrease, slows down. So wavelength decreases and frequency, no change. So nothing happens to frequency, no effect, stays the same, unchanged. Any word could be written. A refractive index. So go back to the question up. The incident angle is 45 and refraction is 30. Take them down. I is 45. R is 30. R is 30. Whenever light goes from air to any other medium. So what you have to do, dear students, you will do n is sine I over sine r. You substitute the values sine 45 over sine 30. Let's calculate it. Sine 45 divided by sine 30. Sine 30. Okay, so this is so this comes to be 1.4, which rounded answer, two significant figures. Okay, calculate the critical angle. So critical angle, what you have to do, you have the equation, the other equation, which is n is equals to 1 over sine of critical angle. Actually, here C I'm using for critical angle, okay? So you will say sine C is 1 over n. C will be sine inverse 1 over 1.4 because they ask us to show that. So you can use the same value, and which comes to two significant figures as 45 degrees. So let's go to the next question. That was unrounded answer 1.414. Okay. With that, the part A is completed. We proceed to the next part. Yeah. So question is, the figure shows the same plastic. It is used to make optical fiber. A ray of light is passing, as you can see. Carefully. Carefully means you try to measure the angles with protractor or as close as possible. Continue the ray until it reaches the other end. So certainly it's optical fiber, and you all know the optical fibers, they have total internal reflection. They have total internal reflection. So light will stay within that. So let's see. You continue with the ruler, this ray first, as it is indicated, like that. The first ray. Now you try to align in such a way, like here is my hint, the way I train my student. The way it is here, it should be same way on other side approximately. So try to visualize with your eyes. If you use a protractor, it will be best. But still, I will just try to make approximately similar angle, although not exactly same, but I will just suggest you to try to look up like that. Do you think these two, they look same? If you suggest that, yes, this angle is similar to this, it means you are right. You're never going to lose the mark. I'm the examiner and I know how we check these papers. Okay. After that, my dear students, again, same criteria. You look how you go from here, similar angle that way. So let's try to draw and see where does it go. Probably it will go out. If you will have more than one over here, an extra reflection, I don't mind, you can do it. But for me, it goes out. So this is the best way, which I told you. Try to adjust the angles until it goes out. So minimum two reflections you have to show. If you have three, it will also be fine. Next question is, state two uses of optical fibers. Optical fibers have actually many uses. Two of them you have studied in details with you. One is the process of endoscopy. So endoscope uses this. Other one, you use the broadband internet communication. Apart from that, it is used in laser surgeries, it is used in military aircraft wirings, okay, so inspection of pipes or anywhere where the things are hard to reach. These are the two as per your learning objectives of Cambridge assessment. Okay, any question? Let's proceed to question number 5. Question 5 says, figure shows a metal sphere S. The sphere has been charged with a negative charge. There is an electric field around S. Draw 4 lines to show the pattern and indicate the direction. So let me tell you, all they should be 4, they should be radial, like as if they are coming from center, and they should be evenly spaced, and the direction will be towards negative. These points you have to keep in your mind. Radial mean like if you're as if they are coming from the radius. So here and then here. Similarly, this way, radial mean as if they are coming from radius. So for all sphere, the lines have to be radial. And since it's a negative charge, so electric field is directed towards negative. So make sure you don't have to draw the line inside because electric field inside a charge sphere is always 0. Do not do that. That's the ideal answer. On the figure, okay, so figure 5.2 shows position X next to sphere S. Let's go down. So there is X, this is the sphere S. Okay, a small negatively charged particle is placed here. Okay, so look, my dear student, this is also negative. And sphere, you know, it is already negative. The sphere is already negative, you all know. So both are negatively charged. You know, if they both are negatively charged, what happens? There is a repulsive force. There is a repulsive force. And whenever there is force, there is acceleration. So what will happen? This negatively charged particle will start to accelerate towards the left side. So state the direction of force on the negatively charged particle at X. Okay, so you know it will be repelled. So repulsion means the motion is away. So the answer is to the left side or away from the sphere. I'm saying towards the left. Okay, left of the page you can say, or away from the sphere you can say. The negatively charged particle X is released from rest. Now you release from rest, describe the motion. As I already told you, there is a force. So force means it will accelerate. Why? Due to a resultant force. So you will say the particle X, the particle at X, okay, will accelerate towards left. Now the reason is since there is a resultant force of repulsion. Okay, that's it. Next part. The figure shows sphere S being spray painted. Sphere S is negatively charged. As the paint particles exit the wide nozzle of the paint sprayer, they become charged with positive charge. They all are positive. Students, if they all are positive, what will happen? They will repel each other. So that's the reason the beam is spreading away. I'm just telling you an idea. So why the particles is spread out? All are positively charged, like charges repel. All particles are positively charged, like charges repel each other. So since all the particles are like charge, any positive, they will repel each other. Okay, now the sphere can be painted by hand or using a brush paint. So you can paint it by hand or brush, but what is the benefit in this way? So advantage is like this paint will be evenly, uniformly spread. Like there will be no additional or thick coating, no thick patches. So you will say paint particles or paint is evenly coated without making patches. Reason, you can say, because all the positive particles, they are being attracted by uh, sphere by same amount. Positively charged paint particles are attracted by negative sphere by same amount to all sections or all parts, you can say. That's it. Many more advantages could be written, but this is one of the best advantage. Let's go ahead to the next question. A car windscreen is covered with condensation or small water droplets. Thermal energy is used to remove the droplets. Thermal energy is provided by three resistors in the windscreen. Figure shows two possible circuits. Okay, three resistors are all identical. If you look at circuit A, it is same path of current. So this circuit is series. Note it down. If you look at this is having branches. So this one is parallel. So first of all, keep in your mind, one circuit is series, circuit A. Circuit 2 is parallel. Series mean if one resistor will fail, others will stop working. Parallel mean if one fails, other keeps working. Okay. State two advantages of B. Hello. So B is easy. The B is a parallel. You all know the parallel has three advantages. Let's write them. So one of them is if one resistor fails or breaks out, others continue to work because it's parallel. The path is not broken. Number two, each resistor in parallel gets full voltage of battery, like which is 12 volt. Third advantage is in case if they ask you like high power, it produces more power because gets more voltage. In series, it is distributed. So power will also be distributed because each is getting less voltage in series. They didn't ask you about series, they asked you about parallel. So answer is as I mentioned. Part two, describe in terms of water particles the process by which the water droplets are removed. This is the evaporation process. So how the condensed water vapors are removed? Evaporation. How? You can say that. So you will first write by evaporation. Now we will describe it. More energetic water particles escape from the surface, okay, by absorbing uh, thermal energy from heater, okay, or by gaining energy. Heater, they already specified in the question. So I gave the reference. Let's proceed to the next question. Part B. Figure shows a circuit with the two resistors P and Q. Circuit is powered by 12 volts. So here is the 12 volt battery or EMF. P is 90 ohms and Q is 70 ohms. You want to calculate current in Q. Easy, using Ohm's law. You know this triangle, students? It says V is equals to IR. So I will be V upon R. The voltage in parallel is same, which is 12 over the resistance of Q, it is 70. So what do? You do 12 upon 70, 0.1714. You round to two significant figures, 0.17 amperes. Don't forget to write the unit. Calculate the energy transferred electrically when the current calculated in B1 is present in resistor for 5 minutes. So write the data. The current is 0.1714 and the voltage we already know it is 12, and the time you will multiply this by 60. So this time will be, when you multiply by 60, the time will be 5 times 60, it is 300 seconds. Electrical energy formula, students, you know it is VIT. Voltage is 12, I is 0.1714, and time is 300. So I will use the exact answer times 12 times 300. It's going to be 617.14. Okay, again, you will round to two significant figures, which becomes 620 joules. Next part. The energy is transferred from the battery by electrical current. State the energy stored in battery. Certainly, the battery has chemical energy. It changes into electrical. Calculate the total resistance of circuit. They are in parallel. In parallel of two resistors, the combined resistance formula is the product of each resistor over the sum of two resistors. So now you have to substitute the values from there. So one of them is, as you can see, 90 and other is 70. All you have to do, plug in the values, 90 and 70. So let's do 90 times 70 divided by 90 plus 70. It is 39.375. I will round to nearest two significant figures, which is 39 ohms. Don't forget to write the unit of resistance is ohms. Do you have any question? No question. Let's proceed to question number 7. Figure shows a barrier at the entrance of a car park. The wooden barrier arm has a weight of 60 Newton. It's labeled. Acting at the center of gravity, you can see it's 1.7 distance from the pivot. So initially the wooden barrier is horizontal. Using the figure, find the clockwise moment. So clockwise moment, which tends to move it this way. So this is the clockwise moment, as you can see. So force multiplied by perpendicular distance. Force in this case, as you can see, is 60 multiplied by 1.7, which comes to be 102. I will round to 100 because it's 3 significant. There's no other way to round less than that. The wooden barrier is in equilibrium. So equilibrium means the total anticlockwise moment has to be total clockwise moment. Total clockwise I already found, which is 102, the exact answer. Now anti-clockwise, let's go back to the question. The mass of the soft iron bar is 23 kilogram. You need to consider that. So I'm using a different color for you to indicate the anti-clockwise this way. So first of all, iron bar, its force is equals to its weight, which is mg, and the distance d is unknown. So we do force times distance. Force is mg and distance is unknown. Plug in the values. So d will be 102 divided by mg. M is 23 and g we use as 9.81. Let's calculate. So 102 divided by 23 times 9.8. It gives us 0.4525. I'll round to two significant figures again, which is 0.45 meters. If you have any question, you can ask me, my dear students. Let's proceed to the next question. Certainly, we'll proceed to its part B. Now B says, figure shows a coil which is attached to a power supply placed below the soft iron. Can you see that? This is soft iron, which is a conductor. Okay. And here is the power supply. When you close the switch, there will be current. I'm just telling you. So question is, state and explain what happens to the wooden barrier arm when the switch in the coil is closed. So certainly when you close this, this is magnetized. And iron is a soft magnetic material or ferrous material. So when you close this, this coil is magnetized, like as electromagnet. It acts as electromagnet. So this will attract this. So when the iron will be attracted down, so what will happen to the wooden beam? It will rotate that way. So this is anti-clockwise. That's the answer. I just explained you. Let's write it down. So what happens to the barrier? So you say barrier rotates anti-clockwise. Why? As I told you. So when switch is closed, the coil is magnetized. Coil is magnetized. Okay, like it becomes an electromagnet. And this electromagnet attracts the iron bar down. So when it attracts downwards, it rotates anticlockwise. I hope you understood, my dear students. Let's move to the next question. I think it's part B, part 2 we will be solving right now. The switch is opened and operator decreases the potential difference across the coil. So when you decrease the potential difference, certainly the current will also decrease. And when the current will decrease, what happens? The magnetism will be weaker. The magnetism will be weaker. When there is a weaker magnetism, there will be less force. There will be less force. So now the switch is open. So operator change. State and explain how the effect on the wooden barrier compares with the previous effects. So there will be less or slower movement. Okay. Or it will move down, but not as much as before. Okay. So you can say smaller movement, you can say, or barrier arm moves slowly. Barrier moves slower. Okay. And the reason is the magnetic field or magnetism or magnetic effect is less. So there is smaller magnetic force on iron, so smaller moment. Moment means smaller rotation. Okay. Last part 3. A student suggests the soft iron core is replaced by steel. There you go. You all know steel is a hard magnetic material. Hard magnetic means it forms a permanent magnet. So when it forms permanent magnet, it will stay attracted. So steel is permanently magnetized. So the barrier would stay in the same position or bar A will stay attracted. Steel forms a permanent magnet. So bar A will stay attracted to soft iron core. It will stay attracted. Why? Because it forms a permanent magnet, as I told you. Okay, any question? No. Let's proceed to question number 8. Question 8 says, an isotope of boron is used in treatment of cancer in brain. Boron sticks to cancer cells in the brain. Isotope of boron is bombarded with the neutrons, then undergoes fission to lithium and alpha particle. One difference between fission and fusion. There are a lot of differences. So fission is splitting, fusion is joining. Fission is splitting of a large nucleus into two smaller nuclei. Fusion is joining of two smaller nuclei to form a larger one. You can say fission requires a neutron while fusion requires high temperature. Okay, let's read the next question. The neutron of boron contains 5 protons, 5 neutrons. Okay, so go to the boron first, as per this data. So 5 protons, down is 5. 5 plus 5, total 10 nucleons, write 10 here. Now alpha you have to know, alpha is 4, 2. Alpha is 4, 2. Alpha is 4, 2. Okay, so alpha is 4 up, 2 down. Now balance. The total on left side are 11. So 11 minus 4, 7. Total left side down is 5. So 5 minus 2, 3. This is how you balance it. Part B. The alpha particles destroy the cancer cell. Suggest and explain one reason why alpha particles are more suitable than gamma radiation for use in this treatment of brain cancer. So alpha instead of gamma. The alpha have least penetration and they have very short range. One of the reason. Other reason you can say the alpha is highly ionizing, more ionizing than gamma, so they can easily destroy the cancer cells. So alpha particles are highly ionizing than gamma rays, so easily destroy cancerous cells. Next, other cancers are treated with gamma radiation. Describe one safety precaution a nurse radiologist takes during the treatment. You all know, my dear. She should reduce the, he or she should reduce the exposure time, maintain as much distance as possible, or shield herself, wear a lead line costume. So reduce exposure time, or you can say must wear a lead lined costume. That's it. Let's proceed to the next question. Question number 9. Figure shows the diagram of transverse waves. Identify all the lengths which are one wavelength. Okay, from crest to crest, one wavelength. Okay, similarly, a distance traveled by one full wave, one wavelength. So Q and V both are the wavelengths. All right. Hydrogen in a very distant galaxy emits electromagnetic radiation, which is observed on Earth. Scientists on Earth measure the wavelength of radiation from a distant galaxy. The wavelength is 918 nano. On Earth, hydrogen in laboratory emits electromagnetic radiation this. Simple. This wavelength from distant galaxies longer than the true observed wavelength longer. What does that mean? Redshift. So redshift means these galaxies are moving further away. Okay? So further the away, higher the speed. Name the effect that the scientists observe. So effect is redshift. What? Redshift. So galaxies further away from Earth have greater redshift. Redshift means increase in wavelength. Okay? And other point is in this, you can say greater redshift mean moving with higher speed. Why higher speed? Hubble's law. Hubble's law says speed of galaxies is directly proportional to their distance. So further away, more the speed. So this tells you universe is expanding. Universe is expanding. Let's proceed to the next question. Question number 10. Oh, we still have part C. Okay, so C says, figure shows the wavelength of electromagnetic radiation of hydrogen from hydrogen in laboratory and from 3 galaxies. Okay. Describe what table shows about the motion of the galaxies. Actually, this is here, what I told you. More the redshift, more the this. So previous answer, actually what I told you can bring here. I didn't know that they will ask this question in 2 patches. So further the galaxies, more the redshift. And about this, we can write the basic answer, just the redshift. Okay, dear students? So here you will write, name the effect. This effect is just red shift. And the red shift tells you that the galaxy is moving away from Earth. Now go to the next question. Some have more redshift, like if you compare this one, than others. More the redshift, further away mean more speed. So that's what I told you, universe is expanding. Question number 10. Stars more massive than sun eventually form black hole. Like red supergiant, supernova explodes. So how a black hole can be formed? So I just told you. So when hydrogen is finished, when most of hydrogen has been changed, converted into helium, hydrogen used up. So what happens? The star expands to form red supergiant. Then what happens, my dear students? This expands. Then this red supergiant explodes as supernova. Yes, when it explodes as supernova, it forms a planet. You can just say nebula and black hole or a neutron star. But neutron star, you don't need to write. They ask you about the black hole. Okay, next part. The star system V404 contains a black hole. The system is approximately 7,800 light years from Earth. What is meant by light year? Light year is the unit of distance. So it is distance traveled by light in space in 1 year. Calculate the approximate distance of the star from Earth in kilometers. Easy. So how do you find distance? You need to know or memorize that 1 light year is a part of your course is 9.5 into 10 power 15 meters. Then your total distance will be 7,800 times 9.5 times 10 power 15. which gives you, after multiplication, 7.4 into 10 power 19 meters. Now you want to change into kilometers. You divide by 1000, the answer will be 7.4 into 10 power 16 kilometers. If you have a question, ask me, and we are done. Thank you. See you for the next variant, and next time we are going to solve paper 6. Take care. Bye bye.